Hey everybody, how are you doing? It's Tim here. I'm on the planet to build a better planet, and I am looking forward to spending some time with you teaching Rust. If you are watching the recording, please kind of click subscribe or follow depending on your where you're watching this, and you'll be updated for future tutorials. So this morning or this evening or today's or the wherever you are in the world, we are going to look at Pascal's triangle. And I suppose you think, well, that's just kind of boring. But I hope that the process of working through this little example is actually going to be kind of informative. And I also want to ensure that you can feel welcome irrespective of the level that you are at. And so the other thing to note is that please say hello in the comments. I'm watching, so, or at least I'm trying to watch, and yeah. And it would be nice to get, I'll just send something out now. It would be really nice to get everyone's feedback. Oh, cool. I wasn't the first person to send something out. So, yeah, it is absolutely wonderful to see you. And let's have fun learning some Rust. Okay. And I need to do this. So I've got a code editor up. I'm using VS Code, but don't feel as though you are required to use VS Code. It's really awesome to see a bunch of people commenting. I recommend, if you have any questions, throw them up there. There is a delay between what you post and what I see. And so please remember that I can't provide immediate answers. However, let's kind of get going. So cargo new, we'll start with a new project. I'm just in the integrated terminal, and I'm going to create my my new project called Pascal. And if you're in VS Code and you're creating it, you need to do something kind of sneaky in order to add sort of the editor, which is to add the file that the folder that you've just created into the workspace. Let's take a look at what Rust has or Cargo has written for us. We've got a name, a version number, and the edition of Rust that we'll be using, as well as a small code example. It's just sort of some dummy code. I can cd Pascal and then cargo run. The output produced with these green words at the start is actually produced by Cargo, which is the build system for Rust, and the output from the program is actually this last thing here. I can add the -q flag to quieten Cargo's output, and then they just get the output from the program itself. So this isn't particularly interesting if you've used a lot of Rust already, and I'm curious as to what your level of experience is. We're going to create a single function, Pascal, and it takes some number of rows. And I'm going to use a U64 as the input type, although strictly that's not necessary. I can use, we could be sneaky and create generics. I want to implement this in a few different ways. I have one that I've written. This is the standard algorithm, or at least it's the algorithm that's on Rosetta code. So I'll just and I'll just actually pull this up. So what on earth is Rosetta code? And Rosetta code is a fun website that provides a lot of algorithms, several thousand or 100, let's say, and implemented in hundreds of different languages. And it's a good way to experiment. Now, this Rust version of, and I'll just add the link. Banner. So here we go. Create a banner. So here is the link to the web page that we are currently looking at. And the problem with it is that it's not very idiomatic Rust. So the formatting is all weird, and you can kind of get there's actually a lot of density in here. It seems kind of difficult to understand what's going on. And I want to simplify this a little bit and explain how to produce a triangle. It also doesn't have any output. We are going to say, yeah. So this is Rosetta code. That's where we're at, and this is what we're going to be doing. And so immediately we can talk about the variable names. The original example has the input argument as n, which is fine, except for the fact that we use this many times. So we use like short identifiers in multiple places in there, and it becomes a little bit difficult to follow what's going on. So as we go along, we've got some number of rows in our triangle that we want to produce, and then we need to kind of go through the column. And then column, actually we'll just initialize a column variable, and I want to start with initializing it to 0. And then I'm going to use we're in position from 0 through to column inclusive. And so an inclusive range includes an equals sign. And now we need to do something a little bit interesting. So we want to print the column. And I also want to add a space. And at the end of the row, I want to add the new line. I don't want to do that early. I now need to update the column. And so there are multiple ways to do this. If you're in school, you might have looked at the previous row and added the two numbers together that are on the left and the right side of the current position. However, we don't want to rely on any previous state. And so there is actually a way to go through this whereby we can use multiplication and division. Except for the fact that we get a compiler error. So let's try and print. So I'm just going to run Pascal for 5. And let's try and produce this output again. Cargo run. We get an argument, an error saying that we can't produce. We cannot assign twice to an immutable variable. We can't update column, which is in line 14. We get instead. I need to declare column or our col argument as mutable or changeable. And there is a warning that this is the wrong operation. So actually, that was a very important fix. And now I can run, I get 0, 0, 0. What have I done wrong? I'm going to check. There are a couple of comments that have popped up. It's nice to see everyone. Hi, Rod and Rod. It's wonderful to see you in the chat. And I now need to have a look at why. So, yeah, right. So we're trying to iterate from 0 to column. but the column is set to 0 at every point, which is not actually where we want. First of all, I should actually start columns. Mathematically, we're multiplying from 0, and so we want the ones to appear on the sort of the border of the triangle, and that will help. So now we'll at least get one iteration. And this is actually the wrong. So this is me translating between the single letter variables and the fixed one. Sorry, and aha! Now we have something that is reminiscent of Pascal's triangle. I start with 1, I have 2 ones, 1, 2, 3, sorry, 1, and it's a little bit difficult to tell what's going on because the spacing is all a bit strange. So let's fix that, because this middle position here, number 6, is the sum of the two previous the two items that are immediately above it, to the left and the right. However, the alignment isn't quite correct, and so I want to show you how to get the alignment working for you. But here is actually, this is sort of all I need to get something that works. Not something that's nice. And so I'll print out, what's the best way to share? Oh, you know what I'll do? I will copy this over to the playground and share. So copy permalink to the playground. I'll post that in the chat. So now you are welcome to play along yourself. This code will also be available on my GitHub account. So the URL for that is coming up. Just a second. Tim Clare. So it's not yet there, but if you go to my GitHub account and go to this repository, the Rosetta code this example will appear there. So that's another good thing to happen. To follow on with. And let's make it look a bit nicer. There are a couple of ways to do this. The nicest thing would be to go to produce all of the numbers that we need, determine how wide the widest number is, and set the alignment up according to the widest number. Now we have some constraints. One is that I only have so many columns in the terminal window, and the other one is that at the moment, I'm purely iterative. I haven't actually implemented, and I'm printing things out as I go. And so I don't have access to the whole triangle while I'm trying to make a decision about the biggest number. It's possible that I could actually pre-compute everything and have almost 2 steps whereby I kind of create a triangle, which is probably going to be some vector of vectors, and and then print that out after inspecting it. However, this will take, let's say, consume memory, and for right now, I think one thing that will suffice is just by adding just by adding a little bit of trickery, thanks to Rust's syntax for spanning, expanding white space. And so when you have a, let's do 7. Now I can print things out into 3. So each of these numbers either takes up 1 or 2 positions, and Rust will automatically add extra spacing as required. It's not quite enough though. What we really want to do, you notice everything is left aligned. What I think is also going to be kind of important is determining how much spacing on the left-hand side is required in order for everything to kind of look like a triangle, or at least an equilateral-ish triangle. So I'm going to use a bit of an idiom, which is a for loop using an underscore, which essentially says, please do perform this task so many times. And I'm going to go from 1 into something inclusive. And that will be 2 times the number of rows. I'm just checking my cheat sheet. So sorry if I am revealing my ignorance, as it were. And rows minus 1 minus row. Then I want to print out like 1 space. Aha, Rust is providing me with a compiler error saying that print is not a function, it's a macro. And now if we try to run our code, I get a nice aligned triangle, which is kind of nice. And I can reproduce reproduce the screenshot that I created for the stream by, I think it was 15. Once we hit more than 3, it starts to look a bit ugly, but not so ugly that it looks completely awful. But yeah, you can see that these last 2 are all slightly out of sync. And so doing this using, I suppose, some real calculations is going to require a different approach. I'm just going to check in with questions just to see how everyone is doing. It's really lovely to see that. Exactly. The illusion has been shattered. I apologize. Let's implement this a different way. At the moment, we're just going through and we are performing the calculation, which is really fantastic. Now, but let's say actually that's not enough Rust. So we're using. I want to learn now a little bit about how lists work. I saw this in another algorithm in the in Rosetta code for a different language, and I'm trying to. So this one I don't have the cheat sheet available for me, and I am going to kind of do it on the fly. So bear with me if I make mistakes. It's kind of all part of the process, let's say. Now we start with something different. Instead of iterating all through our rows, we start with a row and we initialize it as a vector that contains 1. 1 is at the top of the triangle, right? And now for row in 1, so we essentially want to skip the first row. We've already got that. The thing that we want to do is create a left-hand copy and a right-hand copy, and then add the element in the middle. So every new row creates 1 new item. I'll see if I can show you what I mean. Well, first thing I will do is print out this row. Now, Rust provides another piece of syntax for being able to print out vectors, which is a question mark in the placeholder syntax. The question mark is going to ask for the debug output. Debug is a trait which is defined in the standard library. Debug is intended for your use as a programmer rather than end user output. But right now we can use it for the purposes of printing out the argument, printing out the contents. So it's going to be the argument will be, sorry, what is printed to the screen is going to be less user friendly. But we can't ask for display because Rust doesn't know how to display arbitrary vectors of arbitrary types. And so it will give us a compiler error if we attempt to do so. Let's look at so I want a left-hand side is row copy, clone. And the right-hand side is right clone, and then I need to reverse it. I don't want to reverse bits. So it's like, well, how do I reverse a vector? That's a tricky one. Reverse. I've got reverse bits. Oh, wait. Oh, no. Oh, I'm using the same variable name twice. That's not very helpful. So now I'm actually going to use, I'm going to use I as the index and cloning the left and the right. Right, vectors actually have a reverse method so it's implemented in something that's slightly strange. You'll see the type hint is actually suggesting that it comes from a slice rather than being implemented on vector. And that's because Rust will automatically implement methods for it's essentially something similar to dynamic dispatch. Rust will behave as a slice. A slice is slightly more general from the point of view of the type system. And there are lots of things that can pretend to be slices. And when you can pretend to be some other type, and this is enabled via the debug trait, then you can call methods from that are implemented in other types. And so I'm just going to add this in the defined on slice, which is syntactically square braces or square brackets. Available via deref. So the deref trait is the dereferencing functionality. And now the question becomes, okay, so what on earth are you doing now? On the left-hand side, I'll just make this mutable as well. I want to push a new element, which is the last is left. And then I want left. I want the last element of the left-hand side and the first element from the right-hand side. I sum them together, I push them up, and then I'm going to push the I'm actually not entirely sure if I've got this mathematically correct. I'm suddenly second guessing myself. Maybe there's something more sophisticated going on. Last left plus first right. And now I want to left extend, I think. Right. So the compiler is getting very angry at me very fast because I am not, because left is not mutable. Now I have my next row. We have a slight problem, I think, because no, maybe I don't. Let's try and see what this looks like. Now I update row to be this new. I wonder if this was going to work. And so the output will be different. It's nothing like what I was supposed to get. Okay. So I got the first line wrong. So that's not a great start, really. This is a completely unexpected pattern, I must say. Someone is going to scream at me that I am that I'm doing something very obviously wrong. And I wonder if, because we alternate, right? Oh, no. Ugh. Maybe I should go and check what the, I'm going to try, I want to cheat, which is that if rows equals 1, return. This is really awful. I'm expecting that people did. Actually, I'm just going to do less than 2. Return here. The second row is 1, 1. This is awful. This is absolutely terrible. So if there's nothing to do, return immediately. If we have 1, print out the first row. Now print out the second row, which I can hard code as 1, 1. And from this point on, okay. No. Okay, so I got the left-hand side, which, and what I want is, I've done something stupid, which is to, I'm going to try and make it a little bit easier to see. This won't work because I've actually deleted my old code. I'm going to uncomment the implementation that I know works and try and show you what I intend to do here. So running, and there's lots of output, but here's my nice triangle. I want to make it one that's slightly bigger. Aha. Good. Now I can see what I am trying to demonstrate. If there's anyone, there are people actually watching the stream, which is really wonderful. I didn't anticipate that people would watch me muck around like an idiot trying to get this thing done. Okay, it's nice to see that there are like a couple of other New Zealanders. We got one over in New York. Hey, Espres, and And we've also got Justin living over in Edinburgh. Nice to see you all. And I'm a New Zealander living in Wellington, so there you go. But I'm also apparently a very bad programmer, or at least I did something very obviously wrong that you're probably screaming at this. So what I've done here is I've hard coded the first row and the second, and now the third row should be a clone of the previous one, and I add the sum of the two sort of spokes of the triangle backwards. And I thought I could do this by essentially duplicating the left-hand side. So it makes more sense here on line, where are we? 1, 2, 3, 4, 5. 1 and 4, and add 4 and 1. Wait. It's not just a simple clone and an addition of a new unit, of a new element. Everything changes. They all need to be updated. I wonder why I got that wrong. Okay, so... And the annoying thing is I know that there's a very, very simple implementation of this, but I can't remember it off the top of my head. I can go and check. You don't need line 45, do you? Okay, so what I wanted to... I don't strictly need line 45. So I'm just looking at this one. Felix's comment from Felix Metzler. I pronounced the umlaut probably a little bit strangely then. I apologize. Do I need line 45? So my idea was that I would take the left-hand side and the right-hand side, and I would merge them together while adding the new element in the middle. Now, unfortunately, though, the new element doesn't always get added, and now I'm feeling very silly for not being able to fix this. So we only add a new element on odd rows. This is unlikely to be... I'm very unhappy with myself because this is the worst way of implementing this. I feel like, because I remember seeing the example in Rosetta code and thinking, wow, that's extremely elegant. And this is looking far less elegant than what I remember. Cargo run. Now we still have our ones everywhere. Oh, you know what I have? So the problem with left is I'm cloning the entire row. And so it's always going to double in size. I need just the left-hand side. Row, and this will be row len divided by 2. So I'm going to take some slice. I don't... Yeah, so this is a good point. You only need to keep track of one half and only double it while printing it. Yeah, and I think that's accurate because you can always just go back through the other half on the way there. Oh, sorry, on the way. I can go over the same half twice, and I can just go forwards and then back. The problem that I'm facing is that I want to do it without looking at the previous line, except I feel as though I need to. So the third line should really, these two ones on the third line should be a 2, and they're currently not. Let's do that anyway. Going to just try and do something off the top of my head. So I know the position inside the row. Sorry, this is the row that I am. And I'm going to say for j in, where am I? I can go and look at the previous row. I'm just really unhappy. I want to go and cheat and just check Rosetta code because it was there. I saw it. And so there are these extremely elegant recursive algorithms and so forth that are really nice. And then there are these horrible imperative arguments. Imperative. So this here is the implementation of essentially what we started with. I apologize for keeping everyone waiting. This was intended to be like a demonstration of lists and list processing in Rust. And I have started to get distracted, which is kind of not really fair. So this is what we were saying, is that for each element, we just need to we could put a 0 on either side. And then take the sum of... I wonder if that would work. So this is an interesting algorithm. It's really difficult to see what the Ruby is doing here if you're unfamiliar with it. But I think what's happening is that on we're cloning the previous row, adding zeros, and then taking the sum of all of the items along it. And so you should end up with ones anyway. Let's try that. So we start with our original here's our original row. We can just print that out as is. And then it's for essentially as many times as we need. And so 0 through to rows exclusive. There's no equal sign there. And this needs to become mutable. Now the row insert 0 at 0, and then row push 0. So add that to the end. Now, iterate over the row and sum. Let's see, make this right, it doesn't go. Iterate over the row and create a sum of all of the kind of the pairs. Now, so to create pairs, I could do row iter. We're going to encounter ownership issues here, and I wonder if anyone else can spot this. And the API that I'm looking for is a method on iterators called windows. So we want a window, a sort of a slice through here, or through the original, that can take some number. And it might also be called chunks, I think. Let's just check. No. So it's just on the type itself. And there are two variants. We actually don't want windows, we do want chunks. So, oh no, we want windows. So here are our peers. So the left and the right in pairs. We want to update we need to sort of sum the two together. Noting that we'll start with 1. And now we have a problem. Actually, I'll try and make it slightly more obvious. The problem is that we want to update row somehow in place while iterating over it. Now, Rust hates this. It really, really hates that you are trying. So what I want to do is somehow update. Oh, I also need to try to figure out like where I am in the row. Let's say we have enumerate, and then so the enumerate method on an iterator returns an index for each item. And I just want to refactor this so that it's on separate lines again. I know that I just deleted this, but I don't have much screen space available, and it's slightly unclear. It's not helped by the type hinting and so forth, but the problem that I'm going to face is, let's say that I wanted to row I equals item. Well, just left plus right. We don't even need the temporary anymore. Now, I'm very surprised that I haven't got a compiler error, because I would have expected that I would have. Let's try this. Unexpected closing delimiter. Well, first I have a syntax error, which is going to make things a bit difficult for the compiler. Now I get the error that I was expecting. Different. Okay, what's happening here? I have two references, two integers. You can see that from the type inference. This is an iterator type user. Yes, I don't really understand why I expected a slice, but I found a tuple. What happens if I dereference left and right? Why is that? I'm just going to check the comments, because there are often people that Windows returns a slice. Okay. It's not returning the iterators. So Rod has a really good point. So I need to fix this, and I'm asking for a tuple, and so this is pair, and inside, so it's some pair of numbers, and pair, and I can ask for the 0th. I know that this will exist because I know how many items are in my pair. I'm very surprised that we're not getting ownership issues, I must say. You'll probably think of tuple windows from Idiomatic. Maybe I am. Maybe I'm just not thinking. Maybe I shouldn't implement things on the fly. Uh, Mutable borrow occurs here. So this is the first issue. Okay. I cannot borrow row as mutable because it is also borrowed as immutable. And that's strange because... Aha. Okay, so Windows is asking for a sort of a read-only access. And that's a bit of an issue because we want mutable access. So the way around this, or at least a way around this, is to create a copy. No. We still update rows, and then next row here. This will also have the mutation issue right now. And then print out next row, and then row becomes next row. Sorry that the code format is all a bit awful. We immediately get an out of bounds error, which is typical. I just told us that we wouldn't. The length is 1, but the index is 1. That's not fair. The next row is not the same length as row to start with. Oopsie. Just push and don't insert. I love that people are looking at this being like, ah! Actually, that's a good point. We don't even need to do any of this. So this is a very, very good point. We don't need to clone at all. I can just go through and just add extra items. I don't even need I. It sort of doesn't even matter now. Okay, I've got a P. So for every pair, I'm now looking through the... I don't even need to clone. So another thing to do would be... And this is becoming very academic, really. So there's actually no reason to clone the original. We don't need to memcopy across. Instead, I can create a new vector with capacity of the length that I have, and that will be somewhat faster. Like, we're talking microseconds, possibly even nanoseconds faster. But this way we don't actually need to duplicate the original values in memory. We can just have 0 things, and so this will be, yeah, microseconds faster. Aha! Hey, we've got it to work. Woohoo! Now I have my initial row. I don't need... actually, I think it's probably useful to keep this early return here because I assume that you have at least got 1. And in the case that you... Except there's no special casing of 1, unlike the previous version that I had, because if it is 1, then there's no work, there's no work to do. Ah, that's a lie. I need to start from 1. I think. Otherwise I get an extra line. Expected an integer, found a vector of integers. Why have I just rows is the variable that I care about. And so I've asked for, if I get the off by 1, 2, 3, 4, 5, 6, 7 rows in my triangle. Now getting the formatting working is sort of the next thing. I don't really want to. So this is another way to do it. I thought I would be interesting and like kind of create left and right copies and so forth, but it turned out that was a bit annoying. You've seen me get confused with Windows returning a slice and versus where I wanted a tuple. I will just discuss that in slightly more depth, and I think that then we will wrap up because I'm hitting like close to an hour here, and I want to be able to have a stream at about this time, close to weekly. I think it's a fun experience, and hopefully everyone learns a little bit of Rust. Rob's comment comment was that Windows returns a slice, not a tuple. So my original, one of the errors that I was a bit confused about was that I had something that looked like this. Now I'll just copy the working code out, and that I had, so I was doing destructuring in here. So I sort of left and right. I was assuming that the Windows method returns tuples of length that contain items that that for size 2. It will return a tuple of length 2. However, if we go into the implementation of Windows, and I can do that by holding Control, so it looks a bit horrible, a little bit horrible. There's an interesting pattern, by the way. I'm going to copy this across. I just said that I'd finish, but this is an interesting way to validate that. It's kind of, why not just ask for... Anyway, so what's inside a window? A window is an iterator, and so the new method will return some struct, and it will have an implementation of iterator for Windows, which means that the Windows struct that is returned by the Windows method knows how to iterate over itself. Be used in a for loop. If your iterator, if you are attempting to write an iterator for something that takes arbitrary sizes, then you have a problem, because it's very hard to produce fixed width output. So instead of producing fixed width output, the iteration implementation returns back a slice, and you can see actually, so the RET for return is sum, and we can just make this a little bit more obvious. The sum is being confusing. For slightly arcane because an iterator could stop, everything that the iterator produces returns an option. And so here is the subslice itself, which is a view into the original data, which we're calling the V field, and of length size, where in our case it was 2. And because this is of arbitrary length, again, we cannot provide a we cannot use tuple destructuring. It's possible we can do something that's slightly interesting, though. So pair in pairs is See, I like touching the standard. Like, what's special about the standard library code? Honestly, like people are like, oh, the standard library is completely magical. Like, oh, that only wizards can touch the standard library, or only the wizards can implement a programming language. That is the kind of mentality that I think Rust pushes you against. I think Rust should stand up and say, no, our language is introspectable. Our language is accessible. Our language is able to be touched. And I encourage everyone to look into the details of what's going on whenever they are curious. And for me, I want to know how Windows is implemented and why it is that it returns a slice. It seems like the kind of thing that I have an intuition about, and that is something that you should encourage in yourself. Have the courage to be curious. Anyway, so thanks, Rob. No, I didn't want to put you on the spot. But yeah, okay, so we can actually match on slices. And if we have the case where we have a left and a right, then oh gosh, it's possible for us to use something that looks like a variable assign, like we can use variables in the right way. And if we want to be sneaky, we could say that this is actually unreachable. Now, what we're saying here is we guarantee to the compiler that other patterns will never occur. Now I'm wondering, do we even need the match statement? No, we don't. We can just match on a slice. No, we can't. Refutable pattern. Okay, so what this is saying is that the type system does not agree. The type system is saying, Tim. Windows is returning a slice. This could be of arbitrary length. And you are only providing me patterns that will fulfill a slice of length 2. That will not work, sir. And I say, dear compiler, thank you for your diligence. However, you're wrong in this case. I know that Windows will only provide me slices of length 2. And so it is actually the case that is unreachable. So please, dear compiler, please, if it, go and behave in such, so we can do this. So I don't know if this is more readable or not. It's probably not. It's functionally equivalent. But yeah, but yeah, this has been a wonderful hour or so. I hope that you have learned something and that my frustration at the compiler has been beneficial to you. I am looking forward to teaching you more Rust and learning more Rust as I go through. Please do the follow thing. You can also find me on Twitter or X or Mastodon. Yes, this has been a wonderful experience, and I look forward to seeing you in the future. I'm just going to comment on one more thing, is that Windows probably isn't idiomatic these days. And I agree with this. So I've actually just removed the code from the screen. So but we had this method row.windows, and this was the best that people could do with Rust 1.0. And now you could expect that with const generics and with some other functionality that has been added to Rust since the initial public release, that we could create something that is slightly more ergonomic. It's been a real pleasure to talk to everyone. Again, I encourage you to add suggestions for future streams and to keep the motivation up. I'm really curious to see what you're building with Rust and so forth. I should hang up, otherwise I never will. Okay, take care everybody. Have a lovely day. Bye bye.